Okay, let's continue our conversation of differentiating weird stuff and have a look at differentiating logs and exponentials. So we'll have a bit of a break for trig for now, but don't worry, trig is coming back. Yeah, so let's have a look at how to differentiate logs and exponentials. Now, if you remember, and if you haven't, if you're not aware of this or you haven't already seen it, check out my video introducing exponentials, and you'll realize that the whole idea of e to the x, the whole reason we came up with this number e to the x, was that it can't be differentiated, or rather, it differentiates into itself. And this is a lovely little trick with this function, and it's the whole reason the number e came about, more or less. I know I'll get a well actually, and yeah, well actually it didn't, but a nice way of us visualizing it, as I did in my video, was that it is a function that differentiates into itself. So d dx of e to the x is e to the x. And that is something we should remember. That is a very, very nice little trick that will come in very useful. So next question becomes, what if I have something like e to the 2x? What does that differentiate into? Well, for this I'm going to be using the chain rule that I haven't introduced here yet. I'm going to introduce formally next video, but just like in the last video on sine and cos, I'm going to kind of tease it a little bit. I'm going to tell you that in order to differentiate something that has an extra number in the e to the 2x, I'm going to take the argument, the thing that the function is acting upon, and I am going to differentiate that. So the derivative of 2x is 2. And then I'm just going to plop the old function back where it was. And this is a very nice, easy little trick. E to the anything x differentiated, you just bring whatever's in front of the x down to the front. If it was something like e to the x squared, well, as I said, you would differentiate the argument. So the derivative of x squared is 2x, and it would become 2x e to the x squared. The key thing being the e doesn't change, the argument doesn't change, we just add something in front of it. Now, this becomes quite useful when we're trying to differentiate something that doesn't necessarily have an e in it. So, for example, 2 to the x. How would we go about differentiating 2 to the x? Well, we're going to use a little trick with e's and luns. And if you're not too happy using e's and luns, check out my playlist on them. So, 2 to the x. What I'm going to do is I'm going to put this inside an exponential function. And yes, I know it's already an exponential function, but I'm going to put it inside an exponential function using an e. And specifically, I'm going to put it in an e to the ln. And I'm going to plop it, 2 to the x, inside an e to the ln. Now, the reason for this you'll see in a second, but the reason I can do this is because the e and the ln cancel out. These two things are the same, yeah? If I have e to the ln something, the e and the ln cancels, and I'm just left with 2 to the x. So I'm allowed to do this. The reason that I have done it might be a little bit trickier to kind of visualize. But it breaks it down like this. E to the ln 2x. I can have a look at this ln to the 2x, and I can bring this x, using my log laws, down in front of the ln. So it becomes e to the x ln 2. And again, I haven't changed anything, I'm just rearranging it using my log laws. And now I have got e to the x times by a number, let's say a. And I know that when I want to differentiate e to the x with a number next to it, that number just gets brought down. And I end up with the number, which is ln 2, being brought down to the front, and then my whole e function being left after it. So it's ln 2 e to the x ln 2. E to the x ln 2, well, I can work my way backwards. That x can go back up here, my e and my ln can cancel, and I simply get ln 2 times 2 to the x. So just using this factor that e to the x is so easy to differentiate, and using some basic log laws, I can rearrange things as I wish and get some nice differentials. Now, the very last thing that I want to quickly cover is, what if we just have a ln? What if there's no e's involved, we just have ln of x? What does that differentiate into? Well, maybe kind of unintuitively thinking about it, it differentiates into 1 over x. Let me write that properly. d dx of ln x differentiates into 1 over x.